Season 3, Forces in Motion, Physics in the Necrotic World, Episode 94, Mainly Elastic. Welcome, strangers. Not all elastic distortions are linear, in that they stretch at a constant rate. Sometimes they are non-linear, in which they don't stretch at a constant rate. But for example, like rubber bands, they could have a curved sort of thing going on for them. Particles vibrate faster when stretching, so more force is required so that the material can be toasty, in that it can be somewhat heated up. These graphs are still the force on the y-axis as a dependent variable, and extension on the x-axis as an independent variable. More force is needed to stretch, so this has a higher curve than unstretch, so this has a lower curve. Elastic deformation, elastic deformation, not disformation, deformation. Elastic deformation is reversible, so the spring has not exceeded its elastic limit, so it has not gone over the point of no return in terms of its stretchiness. Ideally, beds should have elastic distortion for bed springs, but over time, they can wear and get broken. Like if you jump in your bed too much over time, it will just break. Yeah, very scientific. Not really. Okay. Yeah. Elastic deformation is okay, wait. Elastic deformation is reversible, so the spring has not exceeded its elastic limit, so it has not gone over the point of no return in terms of its stretchiness. Ideally, beds should have elastic distortion. It should have elastic, not inelastic. Beds should always have elastic distortion for bed springs, but over time they can wear and get broken down, so they exceed the elastic limit, so this now becomes inelastic distortion. Steeper gradient means steeper gradient means stiffer spring. Beyond the elastic limit means at that point the spring is now permanently distorted. Yep. See you next time at Physics in the Necrotic World. This is your host, Rimona Christian. Out.